So I'm presenting this paper on behalf of myself, Yelena Desh, and Ken Collins of Disaster Management Group. And I'm a consultant to the company. So the outline of the paper, so we are going to present the results of our development of application for video processing. And the aim of this application is to detect undesirable contact. A distance between people gets shorter than 6 feet, and measure the duration of the undesirable contact. Though this effort consists of two major parts, as people detection and tracking. When we detect, locate and track people in 3D scenes, and calculate people's trajectories, and detect, track and crop images of people faces in 3D scenes, save crop faces, and use it to build an image database based on that. And finally, people recognition and identification. And we use artificial intelligence and machine learning techniques to model the appearance of faces and to classify and identify people using a registry database. Possible application scenarios of this effort is like if you have a, say, a 3D scene, a room, and any place where there are more than 2 people moving around. And the simplest application scenario when one person is sitting in front of the screen, like I'm sitting now. And there are more persons that can come close to this first person. And we track those unwanted contacts and find out when the distance between those people gets shorter than 2 meters, 6 feet. And the use of surveillance cameras to implement this tracking, and the surveillance duration time is up to 1 hour. Then the final the final stage of this processing is report start time, duration, and the contact IDs for each instance. Important is to know that we use MATLAB as the platform to develop this application. And MATLAB has lots of capabilities, including image processing, video data processing, computer vision, and deep learning, and artificial intelligence. This is the general data flow, the algorithm data flow that we implement using our application. So the first stage is camera and video recorder. It's image acquisition. Then we do image segmentation to detect face images of the people present in the scene. Then we do face recognition, feature extraction, and classification. And this all done in, say, in real time. And what's important, we train our classifier in order to achieve correct recognition of people present in the scene. And the other important part is localization and mapping procedure that calculates people trajectories, time history, and identify the unwanted crossing events. This is the procedures that we use to track people. So you have several frames that extracted from the video, And then we apply tracking algorithm, which can be Kalman or point tracking. Choose a keyframe, and out of several keyframes, we can extract and store trajectory of the people presented in the scene. This is a short description of our DMG SmartTrack algorithm. So the video streaming acquisition, video detection, tracking, localization of multiple people. And what's important, we use a calibrated camera, because if you say, if you have a video acquired with a surveillance camera, this video sometimes has lots of aberrations, distortions, and also the video itself doesn't provide any information about real geometry, real world geometry. And the camera calibration can, improve the image quality, and can also provide the links to real, the real geometry of this scene. And the object trajectories and timestamp are stored in a history file and used to calculate distances between objects, start time, duration of the contact, and IDs for each instance. When two or more objects come and stay at a distance closer than 2 meters from each other for longer than 2 minutes. This kind of calibration procedure ensures that prepare images, add images, calibrate, evaluate, improve, and export. And what's important, MATLAB provides a very good camera calibrator application that we use to calibrate our camera. And we also improved this calibration to some extent to provide ground truth information for the scene that we capture. And this advanced camera calibration uses a checkerboard pattern like this. And some of the pictures that we take use a checkerboard placed horizontally. And this provides additional information for ground truth. And this is a ground truth information. So the door in my home office is used as ground truth. And I measured the dimensions of this door and calculate the ground truth and the distance from the camera to the door. And it gave me the ground truth information. So this is detection and tracking of people. In 2D, you can see that the curves look pretty smooth. But what's important, that we can achieve a real information about the distances between the people and the time where this unwanted contact occurs. The beginning of this unwanted contact, when the people get closer than 2 meters to each other, and the end of this event. So in this case, in the video, I will show you this duration of this unwanted contact was 96.6 seconds. And now we go to face recognition stage. So we tested several algorithms for face recognition, and we use a machine learning approach to achieve character recognition with high accuracy. The first approach that we checked was an approach based on principal component analysis, which is very common in statistical evaluation and hypothesis evaluation in data processing. So this approach can give us pretty high accuracy when the quality of facial images is good, when illumination is close to ideal, and when only frontal face face images are used to build a classifier. So the accuracy is about 92.5% for 40 classes. So to improve this process of face recognition, we had to apply computer vision, advanced computer vision, and artificial intelligence approach. And the first principle for pattern recognition, that's a kind of pattern recognition rule of thumb. Often the quality of the training set is more important than the quality of the pattern recognition classification algorithm. So we apply deep learning architecture and semantic approach that can provide high accuracy and variant illumination, poor image quality, and other things, well, lots of noise, and for instance, even with the defocus images and blurred images. And we use MATLAB labeling application in computer vision toolbox to achieve this goal. The results of video tracking, and I will show you why the trajectory for my wife was more kind of hectic, more complex than myself, the trajectory of myself, because my wife was dancing. And this is why, tracking the face of my wife was a more difficult task than tracking the face of myself. And besides, you can see that some spurious faces appeared in the scene, which were not actually faces, but some parts of the scene that erroneously were detected as faces. But those spurious faces were successfully filtered out. And now it's about creating and testing 40-person the database. I combined several different databases and use them to train our classifier. And this is the first example of such a database that combined Yale B database and the images of me and my wife taken during the tracking part of the application. And you see then that not all the recognition and ID results were correct, but the total correct recognition rate was pretty good. It was 97.5%. Unfortunately, this case cannot be used as is. This classifier cannot be used as is because these are faces taken in good illumination condition, and the quality of images were pretty good, but it's not typically the case when we use the surveillance videos. So we tested several different algorithms, and the best results was histogram-oriented gradient features that we tested. It was 97.5%. Others were not that good. And then we switched to more practical case. We try to optimize the selected algorithm to meet the use of case acceptance criteria. And the case acceptance criteria are more than 2 or up to 40, excuse me, up to 40 classes with maximum 2 images per class. And the accuracy is supposed to be 85%. If you just use 2 pictures to train the classifier, 2 pictures for each class, it's not going to be very successful. Then the classifier cannot be very accurate, because you have to have more images for each class to train classifier and make it work with high accuracy. This is why we developed a new approach, which is extract as many images from the video, from the surveillance video as possible, and train classifier based on those images, and then use images from the registry to identify people in the scene. So when we train classifier, we label persons as person 1, person 2, and person N, so there's no names for this person. But in the registry, there are photographs with the names. And after the classifier is trained, we can identify those person 1, person 2, etc., and find out who exactly was in the scene. This is the result of training a typical deep neural net with 47 classes, and the accuracy of the test set was 96%. And we used mixed face image database. 9 classes were RGB images extracted from the video files, and 38 classes grayscale images. So this combination is also pretty challenging, but it works pretty well. And this is a result of correctly identifying myself as person 1. But when I just use the same picture, but with a cropped image of my face, the person number 1 was incorrectly identified as another person. This is a result of incorrect identification of a person from Yale database. The whole frame was incorrectly identified as the wrong person, but when I use the same picture of the same person but cropped, it was correctly identified. So something going on which is not good, and we have to improve this classifier in order to make it more predictable and to provide better results. How we are going to do it? We are still in the process of improving our classifier. So we are using augmented image data store with randomized preprocessing operations to help prevent the network from overfitting and memorizing the exact details of the training images. We are improving the neural network architecture and fine-tune the neural network. Then we apply transfer learning to retrain a neural network with a pre-trained convolutional network to classify a new set of face images. I will explain the detail of that. So we start with improving the labeling. And we use a labeling video labeler available in MATLAB to label the objects, people in the scene, and provide ground truth and tracking people. Now, it's about deep learning classifier performance that we achieved so far. I will show you some results. Yes. It's a result of training AlexNet, which one of the deep learning networks, neural networks, with the 73 class mixed phase database. Classes from videos, there are several classes from videos, 61 classes from Yale, and Yale was in another database. So the combination is the total combined number of classes, 73. The accuracy of the test set was 98%. And so we are going to improve these results with the network designer features. MATLAB provides a network designer, the neural network designer application that can be used to fine-tune the classifier and design the classifier to achieve the goal of high accuracy. And what's important that it can be done with transfer learning. It means that the classifier is pre-trained with a certain number of input images, and then it can be retrained and fine-tuned with with a new set of images, but it takes shorter time. It provides better accuracy. And retraining of a deep neural net classifier using transfer learning is pretty straightforward. So below the pre-trained neural network, replace final layers, train the neural network with a new set of data, and predict access network accuracy this way, and then we test it. And the fine-tuning usually works better than feature extraction if the new data set is not very small, because then the network has data to learn the new features from. So now the results, summary and conclusion. Deep learning approach with weak supervision can achieve the goal of designing the classifier that can recognize more than 70 classes using training procedure obtained from detection, training data obtained from detection, training, cropping face images from surveillance video. Poor image quality and flickering animation in surveillance video degrade the performance of common filter tracking. Under these circumstances, a point tracker can achieve better performance. Measuring distances between people in a recorded surveillance video requires ground truth, which can be obtained using MATLAB video labeler application that can enable both acquiring ground truth and setting the phase bounding boxes while tracking moving subjects in the recorded video. Noisy, low resolution and low contrast surveillance video input may require pre-processing to enhance contrast under poor lighting and to improve quality of motion blurred and defocused images like the processing the Panasonic face recognition system uses. The MathWorks Cloud Center allows users to run MATLAB in different cloud environments using reference architectures for Amazon, AWS, and Microsoft Azure, or MATLAB deep learning container for video GPU cloud. So this is it. Thank you, audiences, and I'm ready for the questions.